Okay, it's recording.
All right, well, good morning. My name is Lonnie Sears. I'll be presenting on the new Georgia State Plane Coordinate System of 2022. Who am I? A North Carolina boy, licensed in about 6 states as a surveyor, certified as a certified mapping scientist, or ASPRS, president of a couple local companies here, done GPS control all over the country. Fly a lot of UAVs nowadays as a surveyor, and honorably discharged veteran of the Marine Corps. So the Georgia, you're welcome. So the State Plane Coordinate System of Georgia, this is how we got it divided up right now, the East Zone and the West Zone. And it's good to note that there's a political boundary separating them. The counties, they decide which one they want to be in with help from the state. And right along the middle there, they decide, well, I'm going to be in the West Zone or the East Zone. So that's a political boundary there, separating the two zones, which some people don't realize. It's a political. And that's going to stay the same with the new coordinate system. There should be no changes to that. So NGS is going to do this new state plane definition as part of the modernization of the National Spatial Reference System. They invited written comments by all the states, and then the Georgia stakeholders met in 2019 with our NGS advisor, National Geodetic Survey Advisor. And we unanimously decided that the NGS proposed modernization plan for Georgia would meet our needs and provide no change. We had no input, really, no better ideas than what they had. So we basically just went ahead with it. Now, some states have asked for particular changes to their state plane zones and things like that. In Georgia, we decided what we have is really plenty good enough. And you'll see later on that the distortions for the mapping distortions are well within what we can work with. So why are they changing the coordinate system? Well, with modern GNSS equipment, it allows us to measure things with such higher precision than we were ever able to before. With the old Bilby towers and triangulation networks and things, we were dancing in the street if we could get within, 3 feet, a meter, or 1.5 meters of true coordinate system relative to geodesy, to the world. Nowadays, we're trying to get down to millimeter. So the new 2022 Datums are being launched to improve scientific, geologic, and mapping abilities. So when we're talking about Datums, we're talking about where is the center of the Earth? Where is center of mass or center of gravity? And everything in orbit, of course, is dependent on center of gravity. So scientifically, we base plate tectonics, weather, all kinds of things based on where is the center of the Earth. So, and it changes. It changes with geological changes and other influences. So another thing happening is the U.S. survey foot is going away. So you might be well aware that there's an international foot and a U.S. survey foot, and never the two should meet. Well, you'll get data sets sometimes from a surveyor or someone who works out of state or works in other states, and they give you a survey based on international feet. Well, in Georgia, you're supposed to use U.S. survey feet. So in 1959, the U.S. survey foot was put into law, and 40 states adopted it. And then the other 30 either didn't define it or stayed with international feet definition. So anyway, they're doing away with U.S. survey foot and sticking with international feet. So that's happening also at the same time as the datums. And then west longitude is going away. So right now, if you're looking at mapping, everybody in North America, we always go by west longitudes, right? Negative longitude. That's going away. It's always going to be clockwise now in all the mapping, all the geology, all the geodesy. So since all these changes are being done in 2022, it's a good opportunity to improve the state plane coordinate system. That's why it's being done now. The mapping distortions created by the projecting an ellipsoid onto a plane is going to be greatly reduced. Right now, surveyors use grid-to-ground conversions to be able to use GPS on the surface of the Earth and get ground distances between their points. They got to use a scale factor, a combined factor, one for the projection and one for the sea level correction, called a combined factor, and it takes you from a grid distance to a ground distance. That's going to mostly go away in most places. So like I say, in projecting from a ellipsoid to a flat plane, we use different algorithms here. The Lambert conformal conic. Georgia, we have transverse Mercator, because our state is more north-south. And if you got a more east-west state like Tennessee, North Carolina, they use a Lambert conformal projection to keep distortions at a minimum. Because you take a ball and you flatten it out, especially out on the wings, you get a lot of distortion, or a large scale factor. So it's still going to be referenced. 2022 reference frames based on the same reference ellipsoid. So when I talk about these reference frames, that's where they're moving the center of the Earth. That's where the new calculations say center of gravity has moved over a little bit, a few centimeters here, a foot there, or whatever. So they're going to be published about every 3 years. So based on the same reference ellipsoid, though, the same mathematical ellipsoid model is GRS 80. And then 3 conformal projection types. So here are the guys responsible for making our lives complicated. The National Geodetic Survey. You can go onto their website and find out all the formulas, the approach, the reasoning. Everything is right here. So linear distortion at the topo surface. Distortion for design is evaluated at the topo surface, minimizing range in the mean distortion in the zone. And it's accounted for. Now, this is the new zones, okay? This is the definition of the new zones. So instead of being on the ellipsoid, where you've got the imaginary surface of the ellipsoid and bringing state plane coordinates down onto the surface of the ellipsoid, we're bringing it up to the surface to eliminate a lot of that distortion and ground scale factor. So, and then they're moving some of the meridians of the zones, or the north-south longitude that's held as the center of the Mercator projection. They're moving that to account for center of population, so that there's less people affected by distortion of the mapping, less cities, things like that. So it's not on the ellipsoid surface. Nobody lives or works on the imaginary ellipsoid surface. So likely used in the past because it was just easier to do projections based on the ellipsoid surface. So projected scale to the topo surface or ground, it should reduce that a great deal. And I'll show you some of that here in the future.
Your heading up there at the top indicates some sort of statute?
Yes, in the previous website that I was talking about, I've copied some of these off of their design.
What statute is that?
It's not really not a law or statute. It is their design criteria at the National Geodetic Survey. So some of the procedures, NGS designed zones requested by the stakeholders. And they're trying to limit the zones with 50 to 400 parts per million distortion criteria. So you see the difference there. If you got 50 millimeters or 50 parts per million, you've got 3/10 of a mile, 3/10 of error per mile or distortion per mile. And at 400, you've got 2.1 feet per mile. So you can see how much that affects the actual mapping. So design criteria for low distortion is at the 50. But NGS will assist, but they're not going to design those if people really want one. Like perhaps the Atlanta Regional Commission would like a map distortion just for the Atlanta Regional Commission. They'll help with that, but they're not going to define it for that. So here's I thought this was very informative right here. So we get an idea of what we're talking about when we're talking about distortions and the magnitude of them. So here's the U.S. survey foot, like I was talking about, the states that 40 jurisdictions and have the U.S. survey foot. Some have international, some haven't defined it at all. And that had created turmoil with a lot of federal, state agencies, particularly. So our existing distortion in the east zone here, as you can see, 54% of the population is within 75 parts per million. 52% of the cities. So the further we get from the meridian of the zone, as we do this flattening, as I'm talking about, the more distortion we get out here on the wings. So we're trying to minimize that by having this new state plane definition. So this is state plane coordinate system of 83. There's been a 27, there's an 83, and now there's going to be a 2022. Here's the west zone, the existing. You can see 54% of the zone, 45% of cities and towns are falling behind under 100 parts per million. So it's not ideal. And of course, the existing zones are from the ellipsoid and not elevation, like the topo surface. So here's preliminary design for the east zone, and we're taking it down to 95% of the population is under 75% distortion, 98% of all cities and towns. So it really works a whole lot better. We moved the central meridian a little bit in order to get that. And again, this is preliminary. They might find moving it a little bit one way or the other might work better, and they might do that before it's published. There's the west zone. So 95% of the entire zone's under 100 parts per million. We moved the central meridian about 12 minutes. It's just a much better, lower distortion projection. So then there's, in the new design, there is also a statewide projection. So all states are going to have their zones, and then they're going to have a statewide projection as well, to prevent others from having to invent their own coordinate systems or whatever. But a lot of state agencies, utility companies, you name it, anyone who has to map things statewide will use something like this. Land surveyors will probably not use this. They're going to use lower distortion zones to maintain a better or lower distortion. But see, we're up to 200 parts per million now with this. But as well, having everything on one coordinate system in a GIS or in CAD is preferred by everybody. So a couple of preliminary designs there.
How do those designs go from preliminary to official in some sense?
When they publish this, and that is a matter of debate as well. It was originally scheduled for next month, January, to be published and to go into practice. Now, to have every federal agency, state agency adopt it is going to take months. But once it's published, it's really right now looking more like 2024 or 2025 before it's published. If you remember when NAD 83 came out, it wasn't until about 88 or 89 before it was really published and people started adopting it. And FEMA still hasn't adopted it on a lot of their mapping in areas around the country. They still haven't adopted it. So they're still on 29 vertical and 27 projections on some of their mapping. So when this comes out, you'll probably want to see it written into your contract documents if they need it on this new projection. State agencies, county agencies, they're going to have to write it in and say it's required on the new datum or the new state plane coordinate system. When you get data, you really need to get the metadata with it to know, are you on NAD 83 or are you on, are you on a state plane coordinate system of 83 or 22? When you get a CAD file from somebody, you'll have to find out what the metadata is about. How did they derive this CAD file or this GIS data set or whatever it is? This is going to become a stepping stone. It's going to become a stumbling block if you're not prepared for it.
What is the ramification of the error at a project of ground level? So if you're off by half of a foot on a mile, that doesn't make a lot of difference in how much concrete you use, does it? I mean, I don't understand how it's important.
Well, when you're dealing with cadastral layers in your CAD or boundary lines, property lines, it makes a big difference. There's wars over religion and property, and they're not making any more property. And people will fight over a quarter inch. I mean, lawsuits over a quarter inch on property. So it makes a big difference when you're dealing with property. It makes a large difference when you're dealing with large data sets, like how many miles of power lines do we have on 120 kilovolts? Well, you're going to have to use a scale factor to figure out exactly how many miles you have. You can't go out and measure the whole state. I mean, it's been measured in little bitty pieces and brought in, and now you've got to quantify everything. So on a DOT job, right now, they break it into like 3-mile sections, and they have a separate scale factor for every section along there to get it from grid to ground. Well, now it could be 10 miles because the scale factors are going to be less, profound in the actual stretching of the data. So instead of having 3-mile sections, they might stretch it out to 10-mile sections and make things easier for CAD operators and production. Does that make sense?
Adjacent states are doing similar things like the state of South Carolina or Tennessee, for instance?
They are. Yeah, this is a nationwide thing. The National Spatial Reference System is managed by the National Geodetic Survey, part of NOAA, and all states have an advisor. We have an advisor that covers the whole Southeast. And these people deal with the state agencies. They consult. They're happy to come down and do training for state agencies and things like that on these types of issues. But then again, we've got in the codified laws of Georgia, there are codes that mention the state plane coordinate system of 1983 and the datum NAD 83. So there's organizations like DOT and engineering groups and surveying groups, SAMSOG, that are working to change the laws of Georgia in preparation for these kinds of things, to change what has been written into the law and to be probably less definitive of particular datums to allow in the future for changes to happen without us having to go back and change our laws, to allow, yes, sir.
Yeah, I'm not a land surveyor, so I'm just assuming that you peers, the senior members in your profession are zones, modifying the national codes, was filtering down to different state levels and training the number of people in the profession was coming down. It's eventually being absorbed state by state with the standards for it.
I'm not sure there's a question in there.
I'm trying to apply what you're explaining to us, someone not in your discipline, how other engineering disciplines tackle these issues, similar issues. At the top in the industry, we're relying on you guys to figure it out,
Yeah.
come up with the standards
Yeah, so,
nationwide, and it gradually filters down into the state building code.
right, that's the National Geodetic Survey's task, to manage the National Spatial Reference System, and then trickle down all this information to us at the local level, that we can adopt it and train our staff to adopt this. Because if we're going to share data, as a private businessman myself, I share data with the county or the state, whoever my client is, and then they have to in turn share that data with the federal government or USGS. Well, they're going to require me to be on a certain datum and a certain mapping projection. So now my contract documents say I got to be on this new mapping projection. Now I know how to do it. I deliver it to them as they require. So that's how it comes down.
Good question.
Yes.
I think you said the statewide zone is a new system that's being introduced.
By NGS and managed, created and managed by the National Geodetic
And I
Survey.
know the difference between the central, or I guess the eastern and the western zones and the statewide zone comes down to distortion, but it seems like they're just making it more complicated for everybody to have a couple of options. Wherever you are in the state, you're gonna either have the statewide zone, or you're gonna have your eastern or your western zone. So how important is it to be on one versus the other? I know.
Well, for ease of use,
Okay.
having the lower distortion, not having to mess with grid to ground scale factors,
Okay.
makes the work of a surveyor much easier. I mean, you know, when they invented PVC, everybody became a plumber, right? They invented GPS, now everybody's a surveyor, right? So they get out there and they start getting these magic numbers out of this magic box, and they don't really know what that means relative to things around them, right?
Absolutely.
So this helps surveyors all stay on the same page, engineers stay on the same page, standardize what we're doing, and improve it by reducing distortions in the mapping itself.
I find myself wondering how, if at all, this new regime will affect the boundaries between the states.
No, it won't. It won't. As the boundaries go, I mean, every time they come out with a new datum, latitudes and longitudes change. Most people don't realize that, but the latitudes and longitudes change with the datum. And NAD 83 is the datum. And 0 degrees goes through Greenwiching and all that stuff, right? So as they change the center of the Earth, those latitude and longitude values change small, just a very little bit. But as they're defined and codified, this is a latitude right here, and this is a latitude right here. But if you go out in the field and you survey it, you find there's a monument. It was there, it got stolen about 10 years ago, if you don't remember. But Georgia never paid for that boundary, if you didn't realize it. The guy who surveyed it did not include Chattanooga, so they said, no, we ain't paying you. Yeah, we want Chattanooga, right? It turned out he was about a mile off anyway, crude instruments. But he laid out this line, and it has jogs as much 500 feet. It has jogs where they did a correction and things. It's drawn like a straight line here. But when you zoomed into the map, you'd see that that line has jogs in it. So the boundary is actually established by the latitudes and longitudes at the day of the when they first laid that out, and they set monuments all along this line. This line's been surveyed about, I don't know, at least 5 times. And there's mounds of dirt. You know, they couldn't find iron rods or anything back in the day. They just stacked up dirt. And There's 2 or 3 different lines down there, and some of them have been adopted by others, and
Well, I would say with respect, it's gotta be easier to survey a straight line than than sort of the squiggly verticals there. So, it's hard for me to imagine if we've got different schemes, which may move from one to the other, and 50 parts per million, which means 4 inches per foot, if that's reckoned to be low distortion, it's hard for me to imagine that we've got a golden set of data, that we use the old system and survey the boundaries, we get the same spots all along as the new regime. So I'm just trying to understand what implications does that have, or is that completely wrong?
it's so the boundaries themselves won't change because the monuments that are put in the ground set the boundaries.
Okay.
No matter what the distance was measured back in 1950,
Okay.
the monuments rule. That's law.
That's the answer.
Yeah. So no matter what value we assign
But
to
if
that
you try to
property.
survey it,
Pardon me?
if you try to survey the location of those monuments, they might actually change.
The values may change. Yeah. In fact, they will. In 1927, the state plan coordinate values, like in Georgia West, started in the 1 million, or no, about 500,000. And then the easting started in 1,200,000. Well, when you get from 27 to 1983, now the eastings are in the millions, and the northings are in the millions, and the eastings are in the 2 millions. Because they assign a false northing and easting to the origin of the zone. So that's what will happen here as well, so that the appearance of the values don't confuse you. They won't be close to 500,000, 1 million, 1 million, 2 million. They'll probably be out there at 1.5 million and 3 million. They'll assign a new value of false northing so that just when you see a list of coordinates, trained eye, you can spot, hey, that's not on NAD 83, that's got to be the new 2022.
What about an elevation data with that?
Okay, elevation data is a whole different ball of wax. The National Geodetic Survey, as part of the new Datums, they are doing a new gravity model. They're flying airplanes with gravimeters in them. They're flying the whole United States. It's called a GravD program. And they're flying the whole United States to remeasure gravity so that they can create a new geoidal model. And then they're basing the new geoidal model not based on sea level. In fact, NAD 83 is not sea level, or excuse me, NAVD 88 is not referenced to sea level. 29 was sea level. So we got to get sea level out of our state code, and references of sea level are incorrect nowadays, technically. So the new vertical datums, it's going to change as much as 3 feet in Georgia, vertical elevation values. I mean, water's still going to run downhill, but the values on the benchmarks are going to change by as much as 3 feet on the ellipsoid. And then on the geoid, they're going to change maybe as much as a foot and a half. In fact, down here along the coast, it's going to be much closer to the old NGVD 29 vertical datum that some of FEMA maps are still on. It's going to be closer to that than it is on NAVD 88 vertical datum. But then by the time we get up here to Chattanooga, we're getting a little bit in the other direction. The thing is, the geodesists believed at one time that sea level was the same all over the world. That's just not accurate. Sea level changes all the time from one part, like the eastern side of Florida to the western side. There's a lot of influences, including weather. So what they did, they surveyed a bunch of tidal stations along California's coast, along the East Coast. They leveled between them all, and they decided, all right, this is sea level, we're coming off of this, and then they started working together, and then they didn't match when they reached the Rocky Mountains. But nobody cared if they were 5 feet off in the Rocky Mountains. You only got to take one step over to change 5 feet, right? So they just threw all the slop into the Rocky Mountains. That's NGVD 29. On NAD 83, they took one tidal station up near the Great Lakes and they held that as the gospel. And then everything else was relative to gravity measurements and whatever levels that they still had that they could hold. So it's really not sea level. And this one is going to be based on the geopotential surface of the Earth. The geopotential surface being the geoidal surface as measured by gravity measurements. So it's really not sea level.
So our satellite image is the main source to calculate, to measure distortion.
No, the actual CORS network is the primary control for all of these measurements, all of these mapping, all the plate tectonics, the vertical accuracy, all of that. So there's a streaming GPS station set up. I myself have 68 of them around Georgia. Trimble has a bunch. But then if you build them right, NGS will let your data into their measurements, and it's called the National CORS. So National CORS is the primary control, survey control throughout the entire country. So the little brass discs on the ground, they're secondary accuracies. They're no longer the primary control. The L1 phase center of the antennas on the core stations are horizontal and vertical primary control throughout the country. And that's what all of this is based on. So they're streaming data for 20, 30, 40 years now off of these core stations. And they can measure changes down to the millimeter level. And that's how they're tracking plate tectonics, they're tracking solid earth tides, they're tracking subsidence, they're tracking all kinds of stuff with these core stations. They're more accurate, they're active. They know within an hour if it's moved or if a bulldozer hit it. These little discs out on the ground, they don't know. They just surveyed it 30 years ago. They don't know if it moved. So it's, you know what I mean? So that's secondary now. So it changed surveying. It changed surveying a lot. But a lot of people are using Opus solutions and things like that.
When this takes effect, and let's say you've got, there's a lot of, let's say, federal projects that take years, and they do some surveying, come up with their northern easting, and then when this takes effect, will there be some sort of conversion factor? Because I can pull up a drawing and it's got certain northern and easterns, I can snap a point and see where that is in my spacing. But how will that change, with reference to, let's say I build a project and then I want to do something adjacent to that. I come back to the same spatial, of course I got to resurvey things, but how will the new stuff impact what's already been issued?
Right. There are conversion tools on this website right here, National Geodetic Survey here, state plane coordinates, but on the same website, they have tools that'll take you from 29 to NAVD 88, it'll take you from, it'll do the whole conversion of a data set. If you put it in their format, you got to read how to put it in their format, but it'll take a whole list of coordinates, put it over into a new datum for you. And the new projection will be there before they launch. Those tools will be there before they launch the new state plane coordinate system.
And I guess it would be incumbent upon engineers to write these kind of things into the specifications so that when you do look at an older plan, you know which standard it was measured based on.
Exactly. So that's how to prepare for something like this. The data you're getting today might have to be reprojected into the new datum or the new state plane coordinate system. So you can't just take a CAD file. You need the metadata. You need to know what it's based on, how it was projected, what scale factors were used, all those sorts of things, so that you can take this CAD file or surface model or whatever it is that you're designing with, and you can project it into the new coordinate system. If you don't have that metadata, all bets are off being able to bring it into the new one. But that's a very good question. That's really what you need to walk out of here with, is be prepared for this. The data set you're working with now, know what the metadata is and store it with the data, you know? So then you'll be able to go in and out of coordinate systems as you wish.
Is this information shared with, I guess, global partners? I mean, I know that there's companies that are pretty global and share information between different countries. Are there other countries that are taking this sort of same approach?
Yes.
To standardize their measurements?
Right, on a global scale, you've got the, I'm talking about National Geodetic Survey. There's an IGS, International Geodetic Survey, out of Belgium, I think is where they're headquartered. A lot of European countries, Asia. Yeah.
It's an international group.
It's international,
The
national.
nations are collaborators into an international group.
Exactly.
When it comes down, each country is like a signature.
Yeah.
And
Like our CORS network here in North America, a lot of it is shared with them, so that we've got CORS or GPS base stations all over the globe. And people are sharing data sets so they can model the center of the earth down to, millimeters. So if you think about it, these satellites are circling the globe twice a day, traveling about 4,600 miles an hour. They're emitting about 5 decibels. And for us to be able to take a piece of electronic equipment, get out there and position ourselves down to a centimeter or two, it's pretty awesome. Now to sit there and collect data for 20 years at the exact same point and be able to monitor how much it has moved. So the plate tectonics in North America, how things are causing, and predicting earthquakes, things like that. All this data is used for all of that. So it's kind of amazing.
This is just a layman's question. I'm not in this field exactly, but I'm exposed to it in projects. Like, for example, determination of flood zones and things like that. You said a minute ago, I thought I heard 1 foot to 3 foot elevation differences. I presume there's got to be a correction to everything that's based on elevation, because, for example, coastal property, it's really important to know how close you can get to the water line and things like that. It's usually based on, you got to be X amount above the flood zone. All this is going to affect all that too, right? I mean, if you got old projects with old numbers, and then you got to know whether it's the old number or the new number.
The beauty of it is that the water's not going to change its behavior.
No, I'm saying nothing physically changed with the numbers.
But the value of that flood line, the vertical value of that flood line will change with the new vertical data. So taking your data from one to the other, you've got to go through, like we were talking about, this transformation of data, because gravity changes, tides change, tidal elevations change along the coast. So you're taking the old data that was based off of those tide stations along the coast, and you're bringing it to the geopotential surface. So it's not just add 0.2 of a foot. It's like it changes along the coastline. So there's an algorithm you'd have to use. You take your elevations in with their latitudes and longitudes, hit the button to transform it to the new geopotential data, and then change your contours. So that's all about mapping. That's about FEMA and the way they map using LIDAR and other methods to determine these floodplains. But you're right, it's a big fat hair deal. That's why FEMA has not, that's why FEMA hasn't changed some of these old 29 maps. Because they don't want to get slapped.
Personally, one thing they did do, they back in, I think it was the Midwest floods in the 90s, they recalibrated their the entire United States, I suppose. And I went from being well out of the floodplain to my house being in the floodplain, which I know I'm 20 feet. I mean, it's ridiculous, but And I talked to the guy with the FEMA that actually mapped that area, and he said, yeah, we can't get it that small of scale. It's just,
Yeah, so nowadays, though, they're using LiDAR data sets, and that lets them get these floodplains so much more accurate than using the old cross-section method of, pulling tapes out there and running levels and cross-sections through the woods to the lowest bidder, right? I mean,
Right.
what are you going to get,
But I'm just thinking about his point, though. It kind of comes down to the comparison surface. If you go out and do field work on a new datum that you're comparing back to a base flood elevation that's established in a FEMA map that was published using a different datum, then how do you reconcile that? There's no way to reconcile that.
Well, there is. There are formula you can use. There is the website that I was talking about, NGS website, that you, as long as you got the latitude and longitude where you're working and the elevation, knowing the datum it was on, the vertical datum it was on, you can
Convert the base flood,
that
the published base flood elevation to the new.
who does that? Who's the converter of that?
You have
That would
to.
be the surveyor doing the.
All right, so getting back to the practical example, so we're doing a project near the coast, and which we know we gotta raise the lowest finished floor level 2 feet above the flood level or whatever. So the guys out in the field, it's like, okay, we need, a foot of dirt here. So he's measuring off this new thing, and then my map says, well, no, you gotta have 3 feet here.
That's what I'm talking about.
Somebody's gotta know what the matchup is.
That's why they're putting all this out years ahead of time, so we can prepare ourselves for this and understand that, yeah, these issues are gonna come up, and, how long is it gonna take FEMA to adopt it? How long is it gonna take state DOT to adopt
During the
it?
90s,
It's not
How long
FEMA,
is it
that's
gonna
the problem, is the realtors and the bankers
Yeah,
that aren't
yeah,
gonna give
they'll
you the
say, no,
loan
we
without
can't, yeah,
flood
it's
insurance.
That's exactly
You know,
what you get classified into the flood
Yeah,
zone.
but I mean, it's
Like
a
that.
very
Yeah.
interesting problem, and it's gonna take years to figure out, because you're not gonna have time to wait on FEMA to adopt something when you're trying to build a project in a near a flood zone. You're gonna have to go ahead and take some additional steps. to-
Yeah, I think county ordinances will have to take this into consideration. Surveyors definitely are well aware of this, and
Sure.
they're worried to death about it.
I'm not a surveyor, but, I do work with this. So will the instrument be recalibrated? How does that all, from a practical level? Oh, that is the transformation of the instrument, or?
No, it's within the software that they're running. The GPS is just gonna continue getting signals from the satellites. The relativity of the satellites to the datum is going to not change whatsoever.
So just a matter of them making sure they're on the coordinate, on the datum that they need to be.
Yeah, these datums and state plan coordinate things, these are mathematical models. It's all happens within their data collector. So as they're getting latitude and longitude correction, it's appearing on their screen as state plan coordinate. Well, if they have the wrong zone defined, they're gonna get the wrong answer. If they have the wrong datum defined, they're gonna get the wrong answer. So they gotta have the new ones. So that's another thing, these new datums and state plan coordinate projections, your software manufacturers have to include these in their CAD pack. So you're gonna have to update. If you're one of these guys that's still running AutoCAD 2003, I'm sorry. You're gonna have to spend some money, you're gonna have to get up there. Esri software, I think they're on top of it. Trimble, those guys, they're on top of this stuff. AutoCAD, you can bet your bottom dollar they'll be on top of this.
But it's not gonna be an immediate switch, it's gonna take, like you said,
The adoption,
years
yeah.
of conversions, and the surveying field is not expected to flip to this conversion day one, or they're gonna be a grace period or transition or something like that.
It'll take years of adoption from, federal, state agencies to private individuals, county agencies, The thing is, we're just trying to get more accurate, more precision, less distortion, to make GPS work better, to make, geodesy, the flat plane versus the round earth, to smooth all of this out and make it more accurate. like I started off with, the reason for this is we can now measure down to millimeter accuracies relative to the whole globe. And so we're finding that all these mapping projections and algorithms used in previous decades just are not accurate enough. We could improve on them a great deal, and that's what this is about.
What sort of industry standards are having to take this kind of stuff into, I know this is probably one, but what other standard organizations are taking this kind of information into consideration?
Well, USGS has a big part in this, geological survey. And then NOAA, who does weather predictions and things like that, they have a lot of say-so in this as well. That task National Geodetic Survey, who manages the National Spatial Reference System, they're getting, they say we need better data. We need more accurate mapping. And then NGS has to react by saying, well, here's how we can improve it. But it's mostly federal agencies that are after, lower distortion mapping, better accuracy. Yes, sir?
As a layperson, it sounds like I'm hearing some of the things that we always say in the profession. You got the older engineers who might have been doing this stuff manually. Now we got all this sophisticated software to simulate things. You get somebody straight out of college, you just can't give them software if they don't know the basics behind how that software is built.
Bingo, absolutely, yeah. College, you come out of college, you know some theory, you got a good math background, you're ready to. Yeah, but now you need mentoring, and you need to further your education and keep learning in order to apply this correctly, So.
You can be dangerous with some new software. You don't know what it is.
Oh, yeah. An old survey friend of mine, Billy, Jim Lockhart, he said something I've never forgotten. He said, we now have the capability to screw up on a magnitude previously unimaginable.
Lawyer's job program.
So this is the deprecation of U.S. survey foot. It goes into a little bit of definition here, but again, 2 feet. I mean, why do we have 2 definitions of a foot? What's that about? Why was that brought about? I don't know, but in 1959 they adopted it. 40 states took it, others didn't, and the whole rest of the world is on international feet. So NGS has just taken this particular time and working through the National Institute of Standards and Technology and just saying we're no longer going to support this old definition of a U.S. survey foot. We're going with international feet. Feet's going to be the same across the globe from now on.
How do they differ? How do the 2 differ?
How do they differ? So the 1 foot's defined by 0.3048 meters exactly, and one's yeah. So some people are wanting to basically put in these conversion factors into the state law. I really don't think we should do that. I think we should let the National Institute of Standards and Technology define all of this, and we just accept national standards. We'll see what happens as the new laws are in. That's the end of it. I'm 4 minutes early, so any more questions?
Back in my youth, when I was working my way through Georgia Tech, I worked for a company that was involved in missile guidance systems. And they were being chastised that the rockets weren't landing in the right place. It wasn't the rockets. It's not the problem. It was the maps.
I can't believe that.
Garbage in, garbage out.
Now you'll get it down to the centimeters.
Oh, they-
Correct.
Yeah, the military's had some technology that's just totally spooky, what they can do with a device that'll just fit right in your hand.
Any more questions for Lonnie? If not, I want to thank him for taking time on his day and doing this presentation to us. Thank you. The next session will be at 10:10, live version here, the stream version there, so I'll let you guys have a break quick.